Now, the concept number 3.5, floating point arithmetic. Floating point arithmetic means float versus float. In an operation, both operands are float, and we perform an operation, arithmetic operation on them. It is called uh, floating point arithmetic. The type of the result will be always float. Float versus float, always float. Just for example, 3.5 plus 2.5, 6.0. 3.5 minus 2.5, this is 1.0. 3.5 multiplication 2.5, this is 8.75, and 3.5 by 2.5, this is 1.4. So, float versus float, any type of arithmetical operation you perform, the type of the result is always float, you must remember. But where problem comes, int versus int. Int versus int, the type of the result is always int regardless of its accuracy. Now, as far as plus, minus, multiplication are concerned, there is no problem. When division comes, problem will come. Suppose 5 by 2 is 2 always. You cannot get 2.5. What is the accurate result? 2.5. So, int versus int, always int. Now, you may get a doubt. Suppose if we store this one in a float, what will happen? Just I show it to you. Int a 5, b 2, float c. C is equal to a by b. Now, guess the result. Guess the result. Is it 2.5 or 2? Actually, this is neither 2 nor 2.5. This is 2.0. Why it is 2.0? Simply, you are storing the result in floating point data type. That's why the integer 2 is converted into floating point, and it is printed as it returns 2.0. Understand? Here, actually, where damage occurred in integer division. Thereafter, it returns 2 only. What you are doing, that 2, whatever it is returning, you are storing in float. That's why it is converted into floating point value. That's why 2.0 is coming. So, through a example, I will explain this case. Now, you see, you want to purchase 1 liter milk. 1 liter milk, and you carried half liter bottle. You carried half liter bottle for purchasing the milk. The vendor poured the milk in a half liter bottle. Poured the milk in half liter bottle. Thereafter, you brought this bottle to home and poured the milk in 1 liter vessel. These are the facts. You want to purchase 1 liter milk, but you carried half liter bottle, and the vendor poured 1 liter milk in half liter bottle. You brought the milk to home and put it in 1 liter bottle, 1 liter vessel. How much milk you get? Obviously, you get half liter. Because of this size of this vessel, it may be 1 liter or 10 liters, you get half liter only. Where damage is occurred? Damage is occurred here. While milk is 1 liter milk is poured in half liter bottle, because of its size, half liter milk has overflown. You lost. Then, if you pour it in 1 liter or 5 liters or 10 liter vessel, the result will not be different. Here, the same case where damage is occurred, in the case of division, integer division damage occurred, 0.5 is truncated. How can you get it? How can you recover it? It lost. Then simply you are powering it, putting it in float. That's why its format 2.0 you get. So this point we see practically through a demo. In this demo, let us see the difference between integer division and floating point division. Now you see we have defined a class for this demo, that int and float division demo. Now you see this code, int a 14, b 5, c also int. So here what we are doing, c is equal to a by b. C is equal to a by b we are doing, that is we are making the integer division. Then c's value we are writing, then c's value obviously 2, because int versus int in case of division, in case of anything, int versus int, you may perform any arithmetical operation, the result, the type of the result will be int. But as far as plus minus multiplication are concerned, you cannot find any difference. As far as division is concerned, the problem will come in such type of cases. 14 by 5. 14 by 5, it gives 2 only. Okay, that point, not 2.8. Next one, next int p 14, q 5, and float r. Now the return value, the type of the return value we made as float. Now r is equal to p by q. P by q we made, then r's value we are writing. Now find the difference. Then as I explained to you, then the return value, whatever is the 2, is converted into float. That's why you are getting 2.0. 2.0 is not the correct result, 2.8 is the correct result. So here what happened, actually as a result of p by q, what type of division was made? Integer division only made. So integer was developed, integer was returned, and integer was stored in a floating point value. That means 4 bytes. It is 4 bytes, and this is also 4 bytes, but it is converted into floating point. That's why you got 2.0. Now how can we get correct result? Now you see all x, y, z same values I have given, and all are floats. Now you see z is equal to x by y, and z value you are writing 2.8. And a little more extension I have to make. Now either of these operands are float also, you get the correct result. Simply declaring z float, you don't get, you get a result like this. Always this is very crucial point. People generally in this point they commit mistake. That's why I have given a separate program for this.